graph. As the name implies, it is a graph of velocity against time. It's a graph of velocity against time. That is, velocity will be on the vertical axis, while time will be on the horizontal axis. So velocity will be on the vertical axis, while time will be on the horizontal axis. And this graph, there are three segments that we can have in this graph. One segment is for acceleration, and it slopes from left to right, upwards. Slows from left to right, upwards. That is for acceleration. So whenever you see a segment that slows from left to right, upwards, then we call it it's for acceleration. Then the next one is for retardation. Retardation is the opposite. It slopes. The next segment is for retardation. And retardation is the opposite. It slopes from left to right, downwards. It slopes from left to right, downwards. That's the opposite to that of acceleration. Remember that retardation is anti-acceleration. Okay, so the last segment you can see in the velocity time graph is one that is horizontal, and it represents uniform velocity. Uniform velocity means there is no acceleration. So uniform velocity means zero acceleration. Okay, so meaning that velocity is constant. Okay, so there are three things you can find from your velocity time graph. Three things you can find from your velocity time graph. The first is acceleration, and the other one is retardation. And you can find both of them by finding the gradient of the graph or segment involved. So if you want to get acceleration, all you need to do is to find the slope of the graph the portion of the graph that slopes from left to right, upwards. That's the segment for the acceleration. Whenever you want acceleration, you find the slope or gradient of that portion. Then when you are looking for retardation, you find the slope of that portion or that slopes from left to right, downwards. That segment for retardation. When you find the gradient, it gives you the retardation. And when you want to find the distance covered during the motion, what you can do is to find the area under the graph. So area under the velocity time graph gives you the distance covered. And remember, if it is a trapezium, we know how to find the area of a trapezium. It is half the sum of the parallel sides times perpendicular height. If it is a triangle, you use half base times height. If it is a rectangle, you use length times breadth. So these are three things you can find from your velocity time graph. The first one is acceleration. All you need to do is to find the slope of the graph for the segment for acceleration. And if you are looking for retardation, you find the slope of the segment for retardation. And if you are looking for distance covered in a velocity time graph, you find the area. You find the area under the graph. And remember, the graph can be a rectangle, it can be a triangle, it can be a trapezium. So whichever it is, you use the formula. Formula for area of a trapezium is half the sum of the parallel sides times perpendicular height. That is half A plus B brackets H, where A and B are the parallel sides of the trapezium. Then for a triangle, you use half base times height. Yes, and for a rectangle, you use length times breadth. Now let's take an example and see how simple it can be. So let's take the first example here, and you can read the question.
Example 1. A particle starts from rest and increases its speed